Look at a map of India, and it is tempting to divide the country into two simple categories: useful land and dead space. From a strict survival perspective, the highest value is found exactly where the land is easiest to inhabit. That brings us straight to the Ganga Plains in the north. This is an immense stretch of entirely flat land, loaded with incredibly fertile soil delivered straight from river sediment. This landscape supports mass-scale farming, earning it the title of India's food factory. This photograph shows extensive railway lines converging at a vintage station, proving exactly why that flat terrain matters. Without steep inclines or deep valleys in the way, a massive rail network can spread out with ease, linking millions to their food supply. Move to the edges, and you find a massive 7,500-kilometer coastline. This perimeter acts as a giant loading dock, providing the exact geography needed to build port cities and tap into global maritime trade. The historical rule is simple: where there is water and flat land, there are people. By that logic, the jagged mountains in the north and the blistering deserts in the west are simply hostile obstacles to be avoided. But treating India's geography as isolated zones of good and bad land misses exactly how the continent actually functions. The MPDPACI memory trick maps out exactly how these regions interact. Mummy Papa Dal Pakode Cook India. That stands for mountains, plains, desert, plateau, coast, and islands. Those highly populated, comfortable plains and coastal hubs do not exist in a vacuum. They operate entirely at the mercy of the extreme, seemingly hostile zones that surround them. Every freezing peak and scorched dune serves a specific mechanical purpose in an interconnected survival system where every extreme sustains the whole. Millions of years ago, the Indian landmass broke away from Africa and traveled rapidly northward across the ocean, eventually slamming directly into the Eurasian plate. This collision created a massive carpet push effect. As the two plates crunched together, the rock had nowhere to go but up, folding over itself to create the highest mountain range on the planet, the Himalayas. These mountains stack up over 2,500 kilometers in three distinct tiers. At the bottom, you have the forested Shivalik Hills. Above them sits the temperate Himachal Range. Finally, towering over 8,000 meters high, is the Himadri, a permanent zone of brutal, unyielding ice. That permanent ice is exactly why the Himalayas are known as the water tower of Asia. The massive glaciers trap and store precipitation, eventually melting down to feed the Indus, Ganga, and Brahmaputra rivers year-round. Without those hostile, freezing peaks physically trapping and funneling water down the slopes, the lush Ganga plains would run dry. The food factory is completely dependent on the mountains to survive. But what about the deserts? This photograph shows a lone yak surviving on a barren, rocky slope in Ladakh. It is a high-altitude, cold desert where temperatures drop to negative 30 degrees Celsius, creating an environment that closely resembles the moon. Further south lies the Thar Desert. Here, blistering hot days give way to freezing nights, and the wind acts as a continuous sculptor, constantly shifting and reshaping massive dunes of loose sand across the landscape. That loose sand is an active environmental threat. Carried by the wind, the Thar Desert constantly attempts to spread eastward, threatening to bury the country's central farmlands under layers of barren grit. This photograph highlights the rugged, forested ridgeline of the Aravalli Hills. Moving down to the center of the country, we find a massive, raised, triangular landmass known as the Peninsular Plateau. A plateau is simply an area of relatively flat terrain that is raised significantly higher than the surrounding land. The plateau's western edge, known as the Western Ghats, sits physically higher than its eastern edge. This massive geological tilt acts like a ramp, forcing major rivers like the Godavari and Krishna to flow straight east across the landmass. This rocky terrain functions as a massive subterranean vault, packed with raw industrial minerals like zinc and copper. The modern coastal cities and sprawling trade hubs only function because they are physically built and wired using the heavy metals extracted from this rugged, uneven plateau. Out on the far eastern fringes, geographic positioning creates a totally different extreme. This photograph captures an intense downpour in Meghalaya, a region whose specific topography funnels in moisture to make it one of the wettest places on the planet. To survive these massive floods, indigenous populations practice biological engineering. This image shows living root bridges, constructed by weaving the thick, growing roots of rubber trees across swollen rivers to create permanent, flood-proof crossings. Out in the ocean, the remote island territories hold their own distinct weight. This is the sprawling radial architecture of the cellular jail in the Andaman Islands. Surrounded by coral reefs and India's only active volcano, these island clusters provide critical strategic outposts far beyond the mainland coast. From the rain-soaked hills of the northeast to the volcanic archipelagos in the ocean, the outermost fringes develop highly specialized ecosystems and tactical advantages that serve the wider nation. The comfortable, easy-to-live-in spaces do not survive on their own. They are constantly fed, shielded, and supplied by the harshest environments on the map. The system works precisely because of how the parts interact. The mountains protect, the rivers feed, the plains grow, the desert tests, the plateau gives, the coast connects, and the islands guard. Every distinct climate and terrain functions as a single, inseparable superorganism.